Assalamualaikum warahmatullahi wabarakatuh. Here we are going to present the chapter 3, which is application of differentiation. First, we would like to introduce our team member. First, we have Norazila binti Shafi'i. Then we have Maizatu Ashike binti Zaharuddin. The third, we have Nurul Shafika. And lastly, we have Hawa Akira.
We are very grateful for being able to complete this video assignment as soon as possible. Without a good cooperation from us, we will not be able to complete this project. So I would like to congratulate my teammates for working hard to complete this task. Not forgotten, we would like to say a sincere thanks for the lecturer who taught us Calculus 1, Dr. Siti Afika Muhammad, who is willing to teach and guide us in completing the project given. And also to our beautiful family who never stop supporting us from afar.
What is differentiation? Differentiation is a process finding the derivative or rate of change of a function. The derivative is the instantaneous rate of change of a function with respect to one of its variables. This is equivalent to finding the slope of the tangent line to the function at a point. Application of differentiation. We will demonstrate the use of derivative in solving issues involving rate of change, analysis of function, maximum and minimum problem, and mean value theorem after learning how to calculate the derivative of a given function, which is known as the foundation of differentiation calculus. Additionally, we will discover in this chapter how derivative influence the appearance of function graph and how they enable us to identify the maximum and lowest values of function.
Okay, so what is related rate? Related rates are rate of change associated with two or more related quantities that are changing over time. The procedure is to find an equation that relates the two quantities and then use the chain rule or implicit differentiation to differentiate both sides with respect to time.
The objective of the related rates is to change of one quantity to another so that it can be more easily measured. And the second is to find the equation that relates the two quantities and then using the method which is the chain rule or the implicit method.
So moving on to the problem statement. In a simple physical apparatus, the distance x meter and y meter are related by the equation 1 over x plus 1 over y equal 1 over 10. If x is increasing at a rate of 10 meters per second, calculate the rate at which y is changing when y equal 12 meters.
So given the dx over dt is increasing to 10, we need to find the dy over dt. So we need to use the chain rule method to find the dy over dt, which is dy over dt equals to dy over dx multiplied to dx over dt. Moving on to step 3, because the dx and over dt is already given, which is 10, we need to find the dy over dx by differentiate the volume given by the question, which is 1 over x plus 1 over y equals to 1 over 10. Because we are searching for the y, we first need to rearrange first the equation to only y. By putting the x at the back, that leaves us with 1 over y equals to 1 over 10 minus 1 over x. We need to differentiate 1 over y, which is y power of negative 1 is equals to negative 1 y power of negative 1 minus 1, and that leaves us to negative y power of negative 2. And the last equation is negative 1 over y power of 2. and the same applies for dx. Next is negative 1 over y power of 2 dy over dx equals to, because the minus is already eliminated, and then we bring the front to the back, that leaves us with dy over dx equals to 1 over x power of 2 multiplied by the negative y power of 2. And that leads us to dy over dx equals to negative y power of 2 over x power of 2, because the negative y is over 1. Next, we have to substitute the value of dy over dx and the dx over dt in the chain rule that is being given. So that leaves us to dy over dt equals to the differentiate that we just did before, to multiply by 10, which is the value of dx over dt. And that leaves us to dy over dt equals to negative 10 y power of 2 over x power of 2. Next is we want to find the exact value of the dy over dt. We just need to substitute both value of x and y. So given the value of y is 12, x is 1 over x plus 1 over 12 equals to 1 over 10. And then we calculate it, we get x equals to 60. So lastly, we want to find the value of dy over dx, which is negative 10 multiplied by 12 power of 2 and over 60 power of 2, and we get negative 2 over 5. Therefore, the answer to the question is that the value of y is decreasing at 2 over 5 meter per second. And then we're done.
For related rates is about the rate of change of a quantity by using information about the rate of change of another quantity that related.
Okay, in conclusion, therefore we know that the variable must have a certain relation between them that can be used to find the relation between the known rate of change and the unknown rate of change. It is important to separate out these two types of information, because if you use the information too early, it will lead to incorrect answer.